Hello, everyone. My name is Rudy Leibrandt. I'm a principal product manager in the Amazon RDS and Aurora team. And today I'm going to talk to you a little bit about all the new innovations we've recently done in Amazon RDS. So let's dive right in. So first, to start somewhere, what is Amazon RDS? RDS is a managed relational database service with a choice of popular relational database management engines. And the key benefit of using Amazon RDS is that it removes the significant effort of managing and scaling databases. And what that allows you to do is really focus on your customers. So we do that by making the databases easier to administer, to make the databases performant and scalable, available and durable, and finally, secure and compliant. So 90% of the features we build come directly from our customer requests. And customers typically ask us to innovate on a fairly broad spectrum of categories. So what I want to do for this session is step through these categories a little bit and talk through some of the innovations we've made in each of them. So first, we're going to focus on the choice dimension, the bottom of the pyramid. So when you choose a database platform to support your mission-critical applications and business processes, there's a variety of choices that you have to make to support the needs of your customers. First, a fairly obvious one is you need to know where those users and your customers could be located. Geography, from a geography perspective, or from, just in which parts of the countries they might be based on, or which regions they might be based on. You need to know where you should deploy, in other words. You need to understand a little bit of the performance characteristics of those customers and what they need to have their applications run appropriately. There might be some application architecture considerations to take into account, or regulatory and other considerations. Finally, to support building of these new business applications, you need to really understand which versions of the databases with the requisite features to support applications, Lambda functions, serverless applications, and all of those kinds of things. So, let's talk a little bit through a few of these dimensions. So first, this year we extended the reach of RDS to Africa for the first time and launched the region in South Africa, in Cape Town. Obviously one of my favorite places on the planet, judging by my accent. And we also extended in the US West region with a local zone in LA. So, the place where I live now, California, and Africa is now perfectly covered by the RDS offering. Secondly, we also hear from customers who who have requirements to actually run RDS in their own data centers. And there's a few reasons for that. The first one is something called data residency. And data residency, is the requirement to run your database as close to a regional regulatory area. For example, you might need to, for whatever reasons, keep data in country. And in other cases, actually keep your data in your local data center. And, those needs might be contractual, they might be regulatory, or they could just be normal business and IT reasons. And it's important then for customers to be able to take advantage of some of the manageability capabilities and the automation we have in RDS to make that simple to do. Another reason that we see customers wanting to do this is low latency applications. And those are typically things like, IoT scenarios, manufacturing execution systems. And so we've also heard about some scenarios where, especially now when you look at medical diagnostic system, these things typically require single-digit latencies to meet application requirements. So last year, we introduced for the first time RDS on VMware, which allowed you to run the RDS solution on VMware vSphere on your own premises, in your own data center, giving you the benefit of RDS on premises. And this year, we launched RDS on Outposts, which supports running the RDS offering directly on AWS Outposts. So when I look at some of the core benefits of running RDS on Outposts is first, it provides you with a unified interface and a unified mechanism to manage databases either on premises or in the AWS region. It provides a set of data management techniques and functionality that's required for a hybrid cloud. For example, backing up to the cloud, running local, connecting to local applications, typically the things you would expect. So we currently support the latest versions of the open source engines, MySQL and Postgres. And we plan to support more databases in 2021. So another important requirement when it comes to choice is that the expectation that the managed database should be and stay current with the latest major and minor versions of each of these database engines, and that's important for a variety of reasons. The first obvious one is the new versions introduce new features and functionalities, which makes developers more productive. It enhances the performance of the software, and it also addresses security issues and concerns, right? So, and obviously, no software is without bugs, addresses bugs as well. So we continue to stay up to date with the latest major and minor releases on Postgres, on MySQL, MariaDB, SQL Server, and Oracle. This year we announced support for Postgres 12, which contains a number of performance features and performance enhancement features, and a number of different capabilities that make the solution a lot easier to administer. On the MySQL side, MySQL 8 was now released just about 2 years ago. So most of the work there is on staying current when it comes to minor releases and minor versions. But we also introduced new features. We introduced S3 backup ingestion for MySQL, and also introduced support across RDS for AWS backup, a solution that essentially allows you to centralize your backup and retention strategies across a number of AWS services. We also introduced support for MariaDB 10.5 and 10.4 this year, so both major releases. And you can see there are a number of key features in those different engines, again, that either improve performance, make the solution easier to manage, or add productivity for developers. Also really exciting releases this year on the SQL Server side, where we support now SQL Server 2019 with things like accelerated database recovery. But very, very importantly, also started supporting some of the extra SQL Server components, such as SQL Server reporting services, which is widely adopted and widely used by customers, as well as SQL Server analysis services. So those two capabilities were often requested by customers. And another solution there is distributed transaction management. Most customers, or a large amount of customers who use the distributed transactions, really don't have a way to easily migrate off of it. So to add it to the cloud offering makes it really simple for customers to bring those applications that run on premises and support your businesses into the AWS cloud, and make it really easy for you to manage and maintain it within RDS. And then finally, Oracle. So we support the July 2020 Oracle environment, 2020 patch. You can see the updates is on the slides there, with a number of specific Oracle enhancements. Oracle Spatial in Standard Edition, by example, and then supporting the OLAP cubes for Oracle directly in RDS for Oracle. So carrying on with choice, one of the things that database experts just love doing is copying their databases for different departments and different users to run a variety of analytics and reports, and just to kind of have their own dev and test copies of their databases. And it takes a significant amount of time. So typically what we see here is customers have scripts and lambdas and ETL jobs to make it viable for them to do this. And in some scenarios, there's almost like a 10-to-1 ratio from your productive database to non-productive cases, which supports all of these different database copies. And the key issue here is maintaining all of those scripts and keeping them up to date, and then ensuring that the data that you're sharing with other departments stays current and updated. So, a large amount of work for folks to do. Well, no more. With Snapshot export to S3, RDS now allows you to take an existing backup and export that data into Parquet format. Now, Parquet format is it's the Apache Parquet format. It's a very popular text-based or a binary-based format that essentially compresses data significantly, up to 6 times, and then stores it in a columnar structure. And without going into the details of columnar versus row structure, let's just say that columnar structures are awesome to use when you want to do analytics, right? It makes things like summing data and aggregating data and grouping data a lot more effective than keeping it in your relational database. So once it's in Parquet format in S3, now obviously you can use a number of different tools that support that framework to analyze and to slice and dice the data and to draw insights from it, such as Amazon EMR, SageMaker, Athena, and even Redshift can query data in Parquet format. So it's a very useful functionality, and it's one of my favorite features this year, to be honest. Okay, so we're going to move on a little bit. So that was choice, and you can see why choice is important. As you need to be able to kind of make decisions around architecture and supporting your customers and supporting new features, it's important for us to kind of cover that. But once you've done that, you also need to make sure that things stay secure and compliant. So for security of content and compliance is really a shared responsibility between AWS and each customer. And, here at AWS, cloud security simply is one of the highest priorities we have. In fact, it's the highest priority that we have. AWS data centers are highly secure, and we've implemented a number of strong safeguards to keep customer content safe. So our responsibility as AWS is to help keep the underlying infrastructure secure, customers are then responsible for securing any content they put on the infrastructure. And we assess customers with their part of the shared responsibility by making sure that we support security-related tools, such as encryption functionality to protect content. And then, finally, AWS certifies numerous certification programs, and it really helps customers achieve those compliance goals and make sure that we can keep your databases secure and compliant. So let's dive into a little bit to some of the advances we've made in security over the last year. So we introduced support for Microsoft Active Directory integration a while ago, and the way that it used to work before this latest update is that the RDS for SQL Server instance here as an example, and the directory service had to be in the same VPC. A VPC is a virtual private cloud. So it effectively is a networking construct or a security construct that allows you to group together a number of AWS resources and provide secure access to that. Now, the issue with the way that it used to work is that it essentially forced us to create multiple of these directory services maps in each virtual private cloud or in each VPC. So you had to provision multiple ADs, one per VPC. So now we can use one shared Microsoft AD, and RDS instances in different VPCs and different accounts can now share the same access to the same AD. So this not only improves cost efficiency, but it also simplifies the solution and makes it easier to use. We've then also made a number of enhancements to help customers stay compliant with a number of compliance frameworks by providing more and more control over TLS and SSL configurations. So, with SQL Server as an example, you can now disable security protocols and ciphers. You can, disable older versions of TLS, and you can also disable older ciphers, such as RC4 and TripleS. And this is essential for certain compliance frameworks and is a requirement for a lot of our customers coming from on-premises into the cloud. And, we make these easily accessible through parameter groups, which is kind of the normal way that we make these kinds of configuration options available. And we've done similar things on the RDS for Postgres side, and also on RDS Oracle, we now support FIPS 142 for SSL. Another way that we can enhance or improve application security is by a new feature or a new set of capabilities in the Amazon RDS Proxy. Now, I'll talk a little bit about proxy later when it comes to ease of use. But I decided to just kind of discuss the security-related benefits first. So earlier this year, when we announced the availability of RDS, RDS Proxy, which makes applications more scalable and more resilient to database failures, and finally, of course, more secure. And the one issue that you find is that managing serverless or distributed applications and the credentials associated with those, the database credentials, is inherently complex, right? So if you think about having multiple applications, multiple lambdas, multiple functions, kind of distributed across or scattered across your application landscape, one of the questions you might have is, well, what do I have to do with my application and managing all of those database credentials? And typically, before something like the RDS proxy, you would fundamentally have to instrument each pieces of your code with those database credentials. So you'd have to embed the database credentials in different applications. So if you then have some kind of a policy around password retirement and those kind of things, you have to go back and change all of those different applications, or you have to invent some kind of a way to keep those to keep those passwords maintained. So enter improved security for RDS Proxy, and let me just move on one, and you can kind of see how this works now. So with the RDS Proxy, database credentials and access can be managed through AWS Secrets Manager and AWS Identity and Access Management, or IAM as it's called. And that eliminates the need to embed those application or those database credentials directly in these applications. So if we kind of step through this, the simple Lambda kind of application there, you can see how it requests an authentication token, it receives it, then connects to the proxy, and the proxy then has the ability to use the IAM credentials, look up the secret in AWS Secrets Manager, and connect with the secret directly to the underlying database and establishes the connection that way. And keeps all of that nice and centrally managed, so that it's simple. It's a fully managed kind of platform, so that you don't have to worry about that from an application development or administration perspective. The proxy like I said, is a fully managed service. It scales by itself, and you don't have to be too concerned about what happens under the hood with those kind of things. And that essentially is one way that we can kind of make security not only simple and easy to implement, but conforms to what you would expect from an application security perspective as well. So moving on, so we've covered choice, which was important because one is you need to know where your customers are. We need to understand the performance characteristics. We need to understand application functionality. We need to stay current and up to date. We need to provide a broad array of instance types and things that and regional support to make those things viable. When we step up one into security and compliance is, you need to also make sure that your customers' data and your own data is protected, right? So making sure that we can stay compliant and we provide the tools and the frameworks and all the infrastructure you need to kind of make sure that you can keep your data safe. And then, once that happens, it's also critically important then to have these applications have these applications based on a database strategy where durability and availability has a strong guarantee. So with durability, we generally refer to the data. So the is data safe? Is there any chance of data loss? And there's a number of enhancements we've made there. And then we can talk a little bit further around the availability of these as well. So let's dive into that. RDS runs on a highly reliable and redundant building blocks, ensuring durability and availability of data. So, as an example, when you provision a multi-AZ instance, RDS synchronously replicates data to a standby instance that's in a different availability zone. So, protecting you against the failure of a single availability zone. And it does that automatically. As an ex-DBA, I understand the complexity, and I've burnt my fingers around setting up highly available systems, right, with things like patching and those kind of things involved. It's a significantly complex task, and it doesn't get easier as your application grows. And then obviously RDS has a number of other features that enhance reliability for critical databases, including automated backups, database snapshots, and automatic host replacements. So let's dive in and look at some of the specific enhancements. This is kind of interesting. Often I get the question, well, really, why is making backups faster important? A backup is a backup. And the problem with that is that the longer backups take to complete, if you have to run multiple of them, is you could be affecting the durability of your data. So effectively, you want to have these databases run, or these database backups run, as quickly as possible. So, for a while, Microsoft SQL Server has actually had this functionality that allows you to parallelize your backups. In other words, you can kind of run a command and call a backup, and it then stripes the backups over multiple files. And the benefit there is that the backups, using modern CPU architectures and threads, it has the availability to make those dumps complete really, really fast. So what we've done in one of the latest versions here is we've incorporated multi-file native backup, and we now support that as a way to improve the performance of backups in Microsoft SQL Server. And if you look at the graph there, you can see the performance improvement on the right is significant, right? So in some cases, up to looking at the 4 terabyte restore right at the bottom there, almost a 5x performance improvement in backup, which, will your DBAs will absolutely thank you for that, right? Is the ability to kind of wrap up on those backups and make sure that they complete in time, right? You still have to then copy them to your DR zone or get them off of those environments. So the faster that can happen, the more cost effective that could be. Now, you can also then restore those on database instances with read replicas, right? And we'll go into read replicas in a second. Cross-region automated backups. Now, if you Google RDS cross-region automated backups, you're likely to find a number of scripts, lambdas, blogs around how this could be achieved, right? And, as I said, is most of our requirements come directly from customer requests. And one of the things that customers have asked us to improve on is this, the ability to take a backup or a snapshot and to automate the cross-region copy for that, right? And the reason to do this is basically for disaster recovery. So if something happens with your database in one region or with your application in one region and you want to fail over to another region, having the ability to automate the backups, the copies of the backups to another region is critical. And generally, as I said, done with a lot of scripts. Now, one thing that we see happen often is that a specific set of customers, like Oracle customers, need a feature, or a set of customers need a feature to support their business operations and need it urgently. And this is one of those where it's great to be part of the RDS group, because once we implement a feature like this for one database engine, we can fast follow and support multiple database engines. So this capability, for example, is today supported on RDS for Oracle, and we're planning to add support for other databases going forward. Okay, moving on to read replicas. So read replicas is one of the things that make RDS pretty special. It's one of the things that is actually pretty difficult to design and develop in a standard way. And if you had to do this on premises, and typically what we see these days is DBA teams are smaller and smaller and smaller, and fundamentally have to support more and more different databases. So to do this consistently across a different set of databases and a set of different deployment options is a serious benefit to have, right? Is if you think about your ever-shrinking DBA resources and skills and the amount of systems they have to support, having the same API to support not only read scaling, but a little bit of additional availability is kind of key. Read replicas allow you to scale beyond the capacity constraints of a single database system or a single database instance for read-heavy database workloads. So this year we added support for read replicas in RDS on VMware. So, not only can you do this in the cloud, you can also do this on premises now using RDS on vSphere or VMware vSphere. A nice feature recently is to read replicas for Postgres is the ability to support concurrent major version upgrades for read replicas. So before we introduced this, what you'd had to do is you would have to upgrade your primary instance and then upgrade your read replica instance. And the read replicas wouldn't be available, until everything was upgraded. So you had some choices to make there with when you bring your system online. Do you bring it online when the writer is up, or do you wait for all of the readers? And if you had 15 readers, or the amount of readers that you support, or 5 or 15, depending on how you set this up, that could take quite a while. So with this new version, you can be assured that as you upgrade your primary or your writer instance, the readers will upgrade concurrently, and when they come up, your entire system is available. And then lastly, we introduced asynchronous in-region read replicas for SQL Server, and that's based on SQL Server Enterprise Edition with always-on availability groups. Okay, so again, right, is the ability to take a concept in RDS and then extend it to multiple database engines. And if you're the database administrator there, you really have to only learn one API and one model for these. Although we use the native functionality of these technologies in some cases to create the features. And then just one more on replicas. We also now support mounted replicas. Now, the use case here for mounted replicas is a little bit different from the read replicas we just discussed, which is there to kind of enhance read scale. In the default Oracle environment is the replicas are read only. The read replicas are read only. This is the default. Active Data Guard then transmits and applies changes from the source database to all the read replicas, and you can then have up to 5 read replicas from one source instance. A mounted replica uses Oracle Data Guard, but the replica does not accept any user connections. And the use case for that is generally is a disaster recovery scenario. It's therefore cross-region disaster recovery to kind of enhance the time that it takes to fail over to the second thing, because there's a database that's being fed in real time with transactions, and you can easily switch over if you need to. And you can create combinations of mounted and read-only replicas, and you can also change them. With a simple API call, you can change a read-only replica into a mounted replica. Okay, so then when we skip up the channel to price performance, 2 things here. So price performance is obviously an important thing for our customers. So I'll dive straight in and go to the first one here. This year we introduced RDS support on Graviton instances for our open source engines. And we're pleased to say that our internal benchmark suggests that you can get up to a 35% performance improvement and up to a 52% price performance improvement for these RDS open source databases, so MySQL and Postgres. If you looked at the graphs here, you can kind of see this is a simple benchmark. It basically takes orders per minute on the left and shows you that as we increase orders per minute and as the thread counts for these CPUs increase, you can actually see how the Graviton instances shine at the top end of the scale here. And you can see that on the left on a 16XL and on the right here on just the normal large instance types. And that's a comparison between the Gen 5 instances, so M5, the M5 instance here, and then the Graviton instances, which is M6G. So, it's an internal benchmark. Internal benchmarks are awesome. I encourage you to log on, provision yourself a Graviton instance. You can simply upgrade one of the dev and test instances you have and run your own benchmarks and see how well that performs for your applications. And then finally, an effective way to affect price performance is price reductions. So happy to announce that we've reduced the price for both on-demand and reserved instances for multi-AZ configurations for RDS on SQL Server Enterprise Edition, where it's multi-AZ, and on average, you can see there a performance decrease of around 25%, depending on the region and instance sizes. So lastly, the last section here is on the ease of use side of things. So, from an ease of use perspective, there are a few things that we can kind of talk through. So let me dive straight in. So earlier we talked a little about the RDS proxy. So again, it's a managed, highly available database proxy for RDS that makes applications more scalable, more resilient to database failures, and we've talked about the security benefits of that too. So if I jump on one slide here, one of the key things that proxy allows you to do is to implement a feature called connection pooling. Now, connection pooling is important because, the more connections you make to a relational database, the more resources you consume on that database. And often, running out of connections is something that databases and DBAs really, really kind of fear, because that fundamentally is a downtime event for you. So with Proxy, we can pull these database connections, and the proxy is smart enough to understand a little bit of the session state of these connections. So what it could do is, after you complete a transaction, so I insert an order and I commit the order, and I return and I go back to the application, another order or another transaction can pick up exactly the same connection without creating a new one, and execute more logic through that connection, through that environment. And we call that multiplexing. Now, if the proxy feels it's not safe to reuse that connection, it causes something we call pinning. So it doesn't reuse it. It basically makes sure that the same application with the same context keeps using the same connections, right? Making it really simple for you to reduce those additional connections that you get on those databases. So very, very important feature there. Now, take that into account with the security credentials and all of those kind of things too. Now, the other thing, because we know so much about these connections and the underlying databases, one thing that we can also do is make the failover events a lot faster and a lot more predictable, because we keep the state between the application and the proxy between the database instances. So let's say, for example, that one of those DBs, let's say the blue one at the top there, fails, and we have to fail over to a different region. The application doesn't need to know about that, right? The application is connected to the proxy. We can fail over and do a host replacement, or and quickly then have the application, without it kind of seeing any downtime or maybe just a bit of a latency blip, can then reestablish the connection to a new instance. And effectively what that allows you to do is to have up to 66% faster failover times. So the next slide I have here kind of plots that out a little bit. You can see the orange line over there compares you connecting with a direct, this is to a MySQL database, using the MariaDB Aurora driver connecting to an Aurora MySQL database, and connected to the proxy on the blue line at the bottom. Now, what's interesting is that the MySQL driver has already been tuned for faster failover. So if you have any experience in using the MySQL versus the MariaDB driver, often we recommend you using the MariaDB driver. So this is even better than the MariaDB driver and the way that was implemented previously. So definitely something to look into if improving your failover times is a requirement that you have. So finally, AWS License Manager with RDS for Oracle. AWS License Manager makes it easier for you to bring your existing software licenses from vendors such as Microsoft and Oracle, SAP and IBM to AWS, and centrally manage these licenses across AWS and on-premises environment. So now you can centrally track bring your own license usage for your RDS for Oracle instances with the license manager. That makes it easier for you to stay compliant to these license agreements, whether you run them on premises or in the cloud. Okay, so finally, right? So just wrapping up, we've taken you through a number of the new features and new capabilities across RDS. If you wanted to learn more, here are a number of sessions that you can go and look up that features Aurora and more details into Oracle, SQL Server, and the open source engines. So take a screenshot of that and make sure that you attend those. And finally, thank you. I appreciate you spending time with me. My name is Rudy Leibrand. You can reach me on my handle over there. I'm a principal product manager in the Amazon RDS and Aurora team. Thank you very much.